This is Algebra 1, Unit 6, Lesson 7, Absolute Value. So just as a reminder, the absolute value of a number means the distance it is from 0, and therefore it's always positive. So if we're saying the absolute value of some number is 5, we know that the absolute value of 5 equals 5. But remember that the absolute value of negative 5 also equals 5. So we have two answers for this. X could be negative 5 or it could be positive 5. So when we solve these, we're going to do it twice. We're going to do it once with a positive answer, once with a negative answer. So we're going to try it with an expression, this time inside of our absolute value bars. So we're going to say x minus 5 equals 3. We're going to drop those absolute value bars and do it as is. So we're going to add 5, and we get x equals 8. But we need to do it a second time. This time we're going to say that x minus 5 equals, and now we have to do it with a negative 3. So we're going to add 5 again. This time we get x equals 2. And just to see what that looks like, let's substitute it back in. So if I take 8 minus 5, that gives us 3, sure enough. If I put 2 in here, 2 minus 5 gives us negative 3. We know the absolute value of negative 3 is 3, so that means there's two solutions for this one. The answer could be 2 or it could be 8. They both work. Let's try it again. So we're dropping those absolute value bars and doing it just as is the first time. I'm going to subtract 7. Oops, what's that, 18? Okay. Then I'm going to divide by negative 2. I get negative 9 as my first answer. But I need to do it again. Again, I drop those absolute value bars. This time I want to make my answer negative 25. Subtract 7. Divide by negative 2. And it looks like my two possible answers are 16. So if we'd substitute that in, negative 2 times 16 is negative 32. Negative 32 plus 7 is negative 25. The absolute value of negative 25 is 25. That works. And negative 9 times negative 2 gives you positive 18. 18 plus 7 does give you 25. So they both work. So again, we have two solutions, either negative 9 and 16 both work. What happens if there's something other than the absolute value bar? We've got to get rid of that before we do it twice. So we're going to use that reverse order of operations. So we're going to get rid of this addition subtraction first. We're going to add 7 to both sides. Now we're ready to do it twice, once with a negative and once with a positive. I'm going to subtract 3, divide by negative 6, and then we'll do it again. We're going to subtract 3 and divide by negative 6, so that's a negative. And we get 5. So we have two possible answers. If you would substitute them in, they should give you a true statement. Okay, this one has multiply by negative 7 and adds 9. Again, we want to do reverse order of operation. So we want to start with addition subtraction. So let's get rid of that 9. We want to divide now. Now we got rid of addition, subtraction. We're going to get rid of multiplication, division. We're going to divide by negative 7. And now we're back to where we were before. We've got an absolute value. We're going to do it twice, once with a positive, once with a negative. Oops. We've got 9 minus 2x equals negative 3. and we're going to subtract 9, which gives us negative 6, x equals 3, and we're going to subtract 9, gives us negative 12, divide by negative 2, it looks like we get positive 6. If we substitute those both in, it should work for us. All right, now that we've mastered equations, let's change it to an inequality. No big deal, it's almost the same thing. So we're going to drop the absolute value bars, and we're going to do it with the positive. Divide by 6. Get n is less than or equal to 3 6s or 18. So we're going to put it on a solid number on 3, and then shade to the left. Now, the trick here is when we make this a negative, we've got to flip the sign. And in effect, we're dividing by a negative. So we're going to change that to 6n is greater than or equal to negative 18. Divide each side by 6. We get n is greater than or equal to negative 3. Close circle here, shade to the right, and we want where the two overlap. So our solution is x has to be more than or equal to a negative 3 and less than or equal to a positive 3. If you choose a number in there and substitute it in, it should work. Let's try 0. 6 times 0 is 0. Absolute value of 0 is 0. 0 is less than 18. If we choose a number outside of the common area, let's say, for example, 6. 6 times 6 is 36. Absolute value of 36 is not less than 18. So it's in the solution set. Let me show you one real quick way, an easier way to do that. As soon as you see this, what you can do, you can write it that way. And then do you remember those inequalities that have the 2 signs? We can do that too and just write it like that. You can split it into 2, which is fine, or just put the negative here. And then remember, when you're dividing by 6, you divide everything by 6. So that gives you negative 3 is less than or equal to n is less than or equal to 3. And we're back to where our last answer was. Okay. This one's a little different. I wanted you to see this one. So we're going to subtract 5 from each side to get the absolute value by itself. So I get the absolute value of x is greater than or equal to 6. And then you do it twice. You drop the absolute value bar. Let me get that out of our way. So you say x has to be greater than or equal to 6. So there's a closed circle and shade to the right. And then we're going to do it again. And this time we say x has to be less than or equal. We're flipping the sign because we're changing this sign. So this time we have a closed circle on 6, and we're going to shade to the left. In this case, it's broken because we're looking for numbers that are going to give us bigger than, greater than 11 once we subtract that. So in order to put numbers into the absolute value that are going to be greater than 6, they either have to be greater than 6 or less than negative 6. And let's try another one. Okay, so we're first going to subtract 5 from each side. So I get the absolute value of x minus 2 is less than, we're adding 5 to both sides. I don't know if I said that. So it gives us positive 3. Then we do it twice. X minus 2 is less than 3. And then x minus 2 is greater than negative 3. Or you could do that fancy way where you do it all at once. So I'm going to add 2 to both sides. So x has to be greater than 5. Whoops, less than 5. So put the wrong side, less than 5. And then I'm going to add 2. So x has to be greater than negative 1. If we write that on our number line, x has to be greater than negative 1, open circle, shade to the right, and x has to be less than 5, so it's an open circle, shade to the left, and we want this common area here. So we're going to say that x has to be more than negative 1, but less than 5. So again, we could have done that in the first place right from here. We could have said that -3, change your answer, is less than x minus 2 is less than 3. It would have saved us a little bit of work. Okay. All right. I just want to show you one special case. There's always those special cases. So again, first thing we want to do is get rid of this minus 10. So I'm going to add 10 to both sides. So I get 9 times the absolute value of r minus 2 is less than -63. And then I want to divide each side by +9. So I get the absolute value of r minus 2 is less than 9, what's that, 7, -7? 7 times 9, 63. Okay, is there ever a circumstance where you're going to take the absolute value of a number and get a negative? If you end up with something like this, where your absolute value is a negative, you know the answer to that is no solution. There's no number that we could put in there that's going to give us an absolute negative value. Please try the practice problems. Let me know if you have any questions.